Dark matter. We've been looking in the wrong place for too long. This is the current estimated distribution of energy in the universe. Please refer to my post on dark energy for my reason why dark energy possibly does not exist. However, there is a reason for dark matter, and that is because we have failed to take into account the most abundant substance in the universe. We are spending billions of dollars worldwide looking for this stuff. In Australia alone, we are spending hundreds of millions. Basically, we can compare looking in the freezer for your car keys when they have been on the sideboard the whole time. In this post, we examine the characteristics of space and time. We postulate the possibility that the mass equivalence of space and time is responsible for the effects that we attribute to dark matter. Due to the known properties of Lorentz factor, space and time cannot be evenly distributed. Matter shapes space and time, therefore space and time is something. Logically, it should be considered that matter utilizes space and time to maintain the oscillations that constitute matter. The flow of space and time into matter is responsible for the effect of gravity. This paper postulates that Planck length is a wavelength and is the wavelength of space and time on the surface of the Earth. Lorentz factor is used to calculate the difference in energy in a quanta of space and time outside a gravitational field. The mass energy in a quanta of space and time away from the Earth's surface can be subtracted from the greater mass energy in a quanta of space and time at Earth's surface to highlight that the energy density of space and time is more concentrated near a massive object and is responsible for the properties of dark matter. Planck length could be the limit when it comes to the resolution of our universe, and it is the wavelength of space and time itself. We logically come to the conclusion that the frequency of space and time is 1.84 times 10 to the 43, and that the speed of light is actually the speed of space and time. We can then use the frequency calculated in the previous slide to calculate the mass energy equivalence of a quanta of space and time. 0.137 micrograms, a very significant amount. We can then use Lorentz factor to calculate the mass equivalence of a quanta of space and time away from Earth's surface and subtract that from the mass equivalence at Earth's surface. And we see that there is a residual mass that is postulated here to be the winning candidate for dark matter. Thank you for watching.